Now this is an introduction to the C3 paper. C3 paper is actually simpler than the C1, C2 papers. The main reason is that the C1 and C2 papers are the foundation of the entire core math series. So when you're doing C3, you're actually doing some more applications of what you learned in C1 and C2. That means C3 by itself is nothing. It works on new add-ons to the concept that were old in the C1 and C2 papers. So in order to grasp what's going to be in C3 and what's in store, it is very important to know where the concept of C3 is coming from. And the entire paper is actually incremental. As you do C1 and C2, that is the foundation, that is the most important. And when you do C3 and then on C4, you just add components to the concepts of C1 and C2. So in order to understand the syllabus of C3, it is extremely important to know what is it in C1 and C2 that we have to do in C3, because ultimately the questions are going to be the same. So here is the C1 and C2 syllabus and the topics that we have here. So the first topic that we have is indices and logarithm. In C1 we have indices, and in C2 we have logarithm. This is actually the same concept which deals with exponents, powers. How do we calculate the power of something, or how do we express a number as a power form? For example, 8 can be expressed as 2 to the power 3. And logarithm deals with something that is a bit more difficult. For example, how do you express 2 as a power when the answer has to be 3? So what is the power of 2 that gives us 3? So it becomes like that. Now here in C3, in the C3 syllabus, what we have is the next concept. So we have this one. We deal with a special power. We call it actually the natural exponential functions. It's a special power, and that special number is called e. So it is the exponential function. So we have the same concept of logarithm and indices, but here we apply it to a special sort of a power. It's a number called e, and we call it the exponential function, or the natural exponential function. It has the concept of C2 logarithm. So here we need the concept of C2 logarithm. We need the concept of C1 indices and C2 logarithm. Here we don't call it only log, we call it by a special name called ln, or natural logarithm, because it's the log of a special base and that special number is e. The next topic that we do in C3, it is an extension of quadratics and cubics. Now quadratics and cubics deals with a number of topics here. The first topic that we talk about, it is numerical methods. Numerical methods refer to a method where you solve an equation. Now in C1 we solved a quadratic equation, and in C2 we solved a cubic equation. And numerical methods is a special method of solving any type of equation. And here there are many type of numerical methods, but we do with only one numerical method, and that is called finding the root finding, using the iteration method. There are many ways of finding the root in numerical methods. Actually there are 4 numerical methods by which we solve the equation and find the roots. In C3, the numerical method that we'll be using is the iteration method. In FP1, FP2, FP3, in the other papers, we have other numerical methods. For example, interval bisection method, linear interpolation method, and Newton-Raphson method. So there are many methods. In C3 we have iteration method for finding the root of an equation, and we first learned about it in quadratics, C1, and then in cubics. Now another thing that was part of C1 and C2 is simplifying an expression. In quadratics we can simplify an expression by middle term break, we can factorize it. Then we have changing the form of a quadratic equation expression into completing the square. Then in cubics we can do that by division. We learn that how we do that. So there is another topic that is actually not a topic, but they give a question on simple algebra. You are expected to know how to do simple algebra. So this concept is also coming from here. It's just simple algebra. You have to simplify an expression by taking LCM and cancelling off. So that concept of doing is coming from this quadratics and cubics topic. Now the next question that we have is sketching and transformation, and actually before sketching and transformation there is another topic called functions, and for functions we have the concept of quadratics and cubics, how they work. We need that concept. We need the concept of sketching and transformation, because in functions we have functions and modulus. Modulus of a function. So here what we do, we have a function and an expression, and which we first learned at quadratics and cubics, and we try to evaluate that value. We try to find the composite function. The concept here is to evaluate a function, then to find the composite function, where the special operation of when we put one function into another function, and we have the concept of inverse function, and we have to solve function equation, which is actually coming from the solving of quadratics and cubics. And there's one special concept in functions. It's the domain and range of functions. Domain and range of functions. The domain is the value of x and the range is the value of y, fx. So this is a concept that we have to do in functions. In modulus we have the transformation. So we have functions and modulus transformation. So we have questions regarding transformations. Although we have the transformations included in C1 and C2 like AFX, FX, but here we have two special modulus transformation, which is absolute value or modulus of fx and f absolute value of x. So these two transformations are very, very important for this particular topic. Now the next question that we have is going to be from coordinate geometry. Now in coordinate geometry, here what's going to happen here is that we need the entire concept of coordinate geometry that we learned in C1 and C2. That means we have to find the equation of a line. That is the main question. So the coordinate geometry here, so coordinate geometry, there is nothing new. The whole thing is based on what we learned in C1 and C2. So for example, in C1 we had equation of a line. That line can be a line with respect to another line, parallel to another line, normal to another line, perpendicular bisector line, or that line can be line to with respect to another curve, tangent line to another curve, or normal line to another curve. So we have the concept of the equation of a line, and we have the gradient rules in order to find that. So gradient rules, that's what we did. And here in coordinate geometry, for finding the gradient rules, we need the concept of calculus. Now calculus has two parts, which we call differential calculus or the derivatives, and the other part is the integral calculus or the integrals. So they have two parts. So here in C3, so what we have here is So for derivatives, using the derivatives, we need to find the gradient rules, dy by dx. Now from C2, so from C2, what we need to know here is we need to find the turning point. That means the maximum minimum value. So this concept comes from C2. So in order to do coordinate geometry, C3 does not have any concept. It has no concept that we need. All we need to do is we need to know the concept of C1, how to find the equation of a line, gradient rules, and from C2 we need to know how to find the turning point. Now the main thing here, the biggest topic of C3 is this one, the derivatives. Calculus. So this is the derivatives. So derivatives. So derivatives. DERIVA, derivatives. So derivatives. So what we have here is, let me write it down again. Derivative. So what we have here is that we have every possible formula for derivatives. So we have derivatives of algebra, derivatives of e to the power x, exponential function, derivatives for logarithm, ln. We have derivative for trigonometric function. So we have derivatives for every possible topic. So these are just formula, and we have two rules. So in spite of having the derivative formula, that was not in the C1 C2 paper, higher formula, derivative formula, we also have two derivative rules called the product rule. What do you do when two quantities are multiplied, and the quotient rule when two quantities are divided? Because usually in C1 and C2 we had the addition rule. What do we do when two quantities are added together? We can easily differentiate them, but now we have the product rule and the quotient rule in addition to the derivative formula. Now in C3 there is no integration needed, so we do not have to do any integration in C3. So now I told you that calculus was the most important topic, the biggest topic, and all the formula here. So there will be quite a number of questions on calculus, and one of the concept that we have in derivatives is the concept of implicit differentiation, which is often given in C4. So this is a question that comes in C3, but it is actually given in C4. Implicit differentiation is where you have x and y mixed together. Usually we have explicit equation when y equals to in terms of x, but implicit differentiation, x and y, they are mixed together. So this is the derivative that you have to find, and there is also derivative of growth and concept of growth and decay in this topic, which is exponential function. So this is the concept of growth and decay. So this is a concept. There is a concept of growth and decay coming from the exponential function. So this, most of the thing for derivative is going to go to this thing, the gradient rule. Remember, the gradient rule is a concept of C1 for finding the gradient of a curve, but what we do in C4 is we use the formula and we find the gradient of the formula. That's what we do. So the equation in C3 would be something like y equals to e to the power x sine x, or something like that. Now if you want to find the gradient of that, you need some special rule. So that's what C3 has. C3 does not have any special concept. It has some formula, and all you have to do is use that formula and use it to find the derivative. So it is extremely important to understand that the concepts are coming from C1 and C2, and the formula is coming from C3. So that's why in that respect C3 is a pretty small syllabus. Now the final topic and the second largest topic is trigonometry. So So trigonometry, which comes in C2. So this topic is trigonometry, the second largest topic, or maybe they're equally large. Now for trigonometry, we need to know the concept of what we did in C2, which is the concept of radians and degrees, and we need to know the concept of radians. We need to know the how to solve a trigonometric equation, solving a trigonometric equation. So these things come from C2. So what we have here is we have two types of question. One question is solving a trigonometric equation, which is nothing but from C2, the same thing. And another question is proving identities. Proving identities. So there are two types of trigonometric questions, solving equation and proving identities, and two questions will be given on that. So this covers the entire syllabus of C3. So I have made a mind map based on the syllabus of C3, so it will be clarify the concept even more. So let's take a look at that. Now this is the mind map of the C3 syllabus. Now if you take a look here, this is a question on simple algebra, which is all you have to do is simplify an expression. This expression can be, they can give an algebraic expression, ask you to simplify, or it can be something when you differentiate something, they might ask you to write down the answer in the simplified version. So this comes from C1 and C2. The next topic is the exponential function. Exponential function, you have to know how to solve equations like this, e to the power x or y equals to any number to the power something. You need to sketch this, you need to solve equations like that. And there is a concept on growth and decay, where something is growing very rapidly or decreasing very quickly, and that falls under the exponential function. This comes from the C1, C2 logarithm and indices topic. Now the next one that we have is the functions. Functions is we have to know the domain and range of functions. We have to know composite function, inverse function. Then there is the modulus of a function, where you have to do transformations and you have to solve the equation. Now the next topic that we have is numerical methods, where you are actually solving for the root of an equation. You have to first of all locate the root, and then you have to find the root. And the numerical method that we use here is the iteration method. And then we have, now this topic, differentiation, actually refers to coordinate geometry. There are formula and rules, algebraic formula, exponential formula, trigonometric formula, and there are the rules, the product rule and the quotient rule. So what you have to do in differentiation, you're going to get questions from C1 and C2, where you have to find the equation of a tangent to a curve, normal to a curve, maximum, minimum, turning point, which is all done with the formula of C3 but the concept of C1 and C2. Now the final topic is trigonometry. Trigonometry comes from C2. It was first introduced in C2. There is no trigonometry in C1. You need to solve equations, which was there in C2, and then you have to prove identities. And one thing is very, very important to remember: in most of the sums, almost all of it in C3 is done in radians. So the concept of radian is very important as well. So this is the entire C3 syllabus in a nutshell. Now let's take a look at the actual question paper and what it looks like. So this is a C3 specimen paper. Now the first question falls under functions and modulus of functions. Then the next question, this is a numerical method sum, where you have to find the root of an equation. Then question number 3, the next one, we have a trigonometric proving identity sum, and then you have to solve that equation. So this is a proving identity and solving sum. This is the simple algebra, we have to solve that equation, and at the same time this is differentiation quotient rule. This is divided together and you have to do differentiation. This one is the transformation and modulus of transformation sum. So we have seen a function question, and this is a transformation and modulus of function question. You have to solve, and then you have to find the equation of a tangent. That comes from C1, equation of a tangent. Then the next one is question number 6. This is a exponential function sum. There will be an exponential function sum. This is a growth and decay sum. This is a decay sum, where you have to find the solve an equation of exponential function and logarithm. then this one is another trigonometric sum, and here you have to differentiate. So this is a differentiation sum and also a trigonometric sum. So more or less there will be 7 to 9 questions. So all you have to do is have the structure in your head, and with that structure you'll be able to solve the question easily to know which question we have. So we have a simple algebra, we have an exponential function growth and decay sum, we have a function sum, one modulus and transformation, the other one is basic function, we have two trigonometric sums, and we have a number of differentiation in various places, and we have one numerical method sum.